Okay, we've been looking at the sine and cosine as functions, and in this lesson we're going to look at them in terms of parameters. Okay, so parameters are constants that you find when you write out a function that you can use to control aspects of the function and how it operates, particularly its graph. So we're going to use a very particular setting here. We're going to say that y is equal to c plus a times the sine of b times the quantity x minus d. Or we're going to say y is equal to c plus a cosine b times the quantity x minus d. Okay, in each of these four letters, A, B, C, and D are what we're going to call a parameter. And each of them controls something different. A controls what we're going to call the amplitude. B controls the period of the curve. C controls a vertical shift up and down. D is going to control a horizontal shift left and right. In order to demonstrate this, we're actually going to switch over and take a look at Desmos because it's a pretty good graphing tool and it gives us some idea of the pictures here. Okay, so I'm in Desmos and I'm just going to start by graphing the real simple y equals sine of x. Okay, so there's our basic sine function, and I'm going to put that out there to just demonstrate the four parameters and what they do. Okay, so when we're talking about amplitude, we're talking about the distance from the center line. So in this function, the center line is the 0, the x-axis, and this function has a maximum of 1 and a minimum of -1. Okay, so if I change that number that's in front of sine to, let's say, y equals 2 sine x, I now have the exact same function, but I've shifted the amplitude. Okay, so it still centers at 0, but the maximum is now 2 and -2. Okay, so you should notice that the what do you call it? So what I want to use that the zeros, the places where it crosses the x-axis, are still in the same place. Okay, so like we're still crossing at -pi, -2 pi, pi, and 2 pi, but the amplitudes, instead of stopping at 1, are now stopping at 2 and -2. So this is what that a parameter at the front does. Okay, so just to kind of clarify something here, if I have made that a parameter negative, so let's say we do this negative sine of x, it actually flips over the center line. Okay, so it's actually going to flip over that x-axis, or the center line. So what happens here is where it used to go up, it now goes down, and where it went down, it now goes up. So this is what the negative will do if I put a negative amplitude in there. Okay, so restoring back to the sine of x. The b gives me a bit of the about the period of the function. I'm going to go back to the sketch book for a second to talk about b. Okay, so this b parameter has to do what we call the period of the function. The period is how far do I have to go in the x direction before the function starts repeating itself. Now, the basic sine function repeats itself every 2 pi units. Okay, so from 0 to 2 pi it repeats. 2 pi to 4 pi it makes the curve again. 4 pi to 6 pi it's going to make the curve again. Now I want to be able to control that, okay? So the period is actually controlled by taking 2 pi and dividing it by b. So whatever b is, if I take 2 pi and divide it by that, I'm going to get the period of the function. So for example, if I let b equal to 2, then 2 pi divided by 2 is pi, which means now the function is going to repeat more frequently. Instead of repeating every 2 pi along the x-axis. Now it's going to repeat every pi along the x-axis. So let's take a look at what that looks like in Desmos. Okay, so I'm now back in Desmos. I'm going to put parentheses around the x here, and I'm going to make 2x. Okay, so now we've made the b equal to 2. And if you look at the graph, it is repeating not every 2 pi, right? But the blue graph is now repeating every pi. So between 0 and pi, it's made a full wave in the graph. Okay, so that's going to shift the period. Okay, so that takes care of that. Let's talk about what the C does. So the C, we're going to get rid of this 2x here. And the C just sits out in front. So let's say we make C equal to 2. So let's make it 2 plus sine of x. This causes the entire graph to shift upward by 2. Okay, so if you put the number C and you change it to a number, it's going to cause the graph to shift upward. Okay, so you can kind of see there. We can also make it shift to the right. Okay, and the way we do that is we again put the parentheses around this and we make the minus d. So remember, this is a minus, and let's say we make it minus 2. Now the graph has shifted to the right, and if you look, instead of crossing here at 0, it is now crossing at 2, right? So the whole graph has shifted to the right 2 units. Okay, so the order of the parameters matters. So if I take the order of the parameters, I want to look at them first A, then B, then C, then D, and it will help me decipher the graph. All right, so let's start from the beginning here. Let's get rid of this second graph, and this time we're going to start with the cosine of x. So there's my cosine graph. Okay, our ultimate goal is going to be able to create y equals 3 plus 2 times the cosine of 4 times x minus 5. Okay, so A is 2, B is 4, C is 3, and D is 5. So it's 2, 4, 3, 5. And ultimately, I'm going to argue that I'm going to end up with this green graph up here. Okay? But that's not what we're going to get right away. So let's take this piece at a time. The first thing we want to do is we want to look at the A. So we said in this graph, A, our amplitude, was 2. So that's going to be 2 cosine of x. And if you look, we've shifted the amplitude. We've now gone, instead of to 1, now we're going to 2. All right, so that's our new graph. So I'm going to turn off the cosine graph, and now I've made the cosine with an amplitude of 2. Okay, so we said that the next thing we're going to do is we're going to change the period. Okay, so now we have 2 cosine of 4 times x. All right, so this is the same graph. It has the same amplitude, but instead of now going every pi over 2 pi units, instead of cycling every 2 pi units, it's cycling between 0 and pi over 2. And why is that happening? Because I'm dividing 2 pi by 4. 2 pi divided by 4 is the same as pi over 2. My period is now pi over 2. So if I turn off the green graph, I can see now I have a graph whose amplitude is 2, whose period is pi over 2. Now the next thing that happens is the C. So in our example, C is 3. So we're going to have this thing shift up. So we're going to keep that 2 cosine 4 times x, and now we've shifted up by 3 units. So we took the existing graph and we shifted up by 3 units. Still has an amplitude of 2, still repeats every pi over 2 units, but now it's shifted up by 3. And the last thing we said we were going to do, so let's turn off the purple one, that's our new graph, right, was we're going to make a horizontal shift by 5. So y is equal to 3 plus 2 cosine 4x minus 5. Now, that doesn't look like it's shifted horizontally by 5. It looks like it's shifted horizontally by a wee little bit. But the reality is that if I look at a particular point, right? So this one here, 1.073, right? And I go to here. So I take that back. The original graph is the black one. There we go. Pi over 4. Okay, so what is pi over 4? All right, well, let's see. Let's get the calculator out. Go to the main screen here, clear everything out. Go, what is pi over 4, right? Tells me that pi over 4 is 0.7853. So if I've shifted to the right by 5, I should be at 5.7853, which, lo and behold, let's get the red graph up here. Not that one, that one. I've gone from 0.7853 to 5.78.53. Sorry, 5.7853. So if I go from this black dot to this black dot here, one's on the black curve, the other one's on the red curve, I have actually shifted to the right 5 whole units. It's hard to see it because the graph is repeating itself so frequently, but I have actually made a right shift of 5. It just kind of came along because of the repetition. All right, so this is the final curve. All 4 parameters are in place, the 2 for the amplitude, the 4 for the period, the 3 for the upward shift, and the 5 for the right shift. And this is where we started. Okay? So you started with the cosine curve, and I was able to modify it to get that curve above using the 4 parameters. The one that controls amplitude, the one that controls period, the one that controls the vertical shift, and the one who controls the horizontal shift. All right, so that's it. Thank you.